high frequency material characterization. So how do we test these materials? So for the what we use is a strip line cavity tester, and that's going to be for this lower frequency range of the higher frequency range for 150 megahertz to 2.5 gigahertz. So we use a strip line cavity tester, and that's going to generate an FMR plot, much like you see on the right. So we see our permeability versus the frequency, and we see how well that material performs, and then how lossy that material is. And that again is a resultant plot that gets generated from using our strip line cavity tester. And this is going to be for the high nickel content materials such as molypermalloy from Arnold. For low frequency material characterization, we're going to use a traditional hysteresis graph. The hysteresis graph is going to generate a BH curve plot, much like the one that you see on the screen in front of you on the right side. And we're going to get that full hysteresis loop from the first quadrant, second, third, fourth, and back to the first. So we're going to understand how that material is going to perform from DC to the 20 kilohertz range. So again, lower frequency material characterization. So looking at the testing summary, we currently have Brockhaus testing machines to go DC to 20. That's going to be for those traditional grain or non-grain oriented silicon steels or other types of entry-level steels. But we have the strip line tester to do the high frequency testing, 150 megahertz to 2 gigahertz. And we're looking at adding more testing devices as we continue to explore that middle frequency category. But hopefully this kind of shows a good breakout of where Arnon is from the DC to 1 kilohertz range to where the molypermalloy, the high nickel content materials play from 1 megahertz to 1 terahertz type of range.